Yeah, let me put this into the right folder. Go. Boom. Save. Now we're good. Okay. I wanted to go over a few of them because they're really good, and they were just real good, like real world examples. One of the first ones, and guys, I didn't even write names down, so I'm sorry if you sent this to me and I'm not giving you the credit you deserve. That's fine. If you want to butt in and tell me it was you, that's fine as well. But someone early on last week sent me one about the coronavirus shot, about the vaccine, and the article stated something like doctor gets a vaccine, single doctor gets a vaccine, and he passes away 2 weeks later from it, or maybe it was 2 days, I can't remember. And it was a good fallacy. I mean, it's trying to stoke emotion. It's not really how they define the emotional fallacy per se, but the presumption, the premise was that you get the shot, the vaccine, and the conclusion that they really jumped to was that you'll die within 2 weeks, right? And that's how the headline read. Of course, if you read the article, it was a little different, but that's just how the headline ran to grab you and suck you into to reading it. And I believe out of the 10 fallacies we went over, it was really just hasty generalization, right? The way they define hasty generalization is like that, where it says, um, I think in theirs, the hasty generalization was, if two things were linked and then all of a sudden, boom, therefore A causes B. And that just, I can't think of another one it might be in. It doesn't really seem to fit the other one. And as another hasty generalization, which I did think was interesting that came from this class, was the what candidate you should endorse or vote for based on a demographic, right? Based on like age, race. I think I got a few of these actually, but based on age, race, gender, things like that. So, because you're African American female, you've got to vote for Biden, right? I think that's also a hasty generalization. The premise is that you're a certain demographic, therefore you should do this, and it's not. It's just not true. I mean, now one could say that, okay, well, if you look at the statistics, there are less, let's start like African American. There are more there's a higher percent of African Americans that supported, let's say, Biden in this last election. So it might be more rare that someone that's African American supported Trump. I mean, that's not the same as saying, oh, because you're a certain race, because you are African American, you had to have voted for Trump or for Biden, that's a generalization, right? And I don't know, hasty might not be the right word, but definitely a generalization, and it's just not true. I mean, it's really not. I mean, we can prove that because not 100% of the population for a certain demographic voted for either of the candidates, right? So therefore, it's easily disproved. It's just a really kind of almost a bigoted generalization. And then there were a few more. Hold on. I like some of these as well. Oh, I noticed this happen in my it didn't. I was not in the conversation, but I was at the table when this happened, and I thought it was a very interesting one, especially with current current topics. And I kind of jotted it down. Oh, yeah. So let's say person A. Person A stated, hey, you know what? I'm really kind of worried about the stimulus checks. We're getting these stimulus checks. It sounds great, but he goes, or he was a he, yeah. He goes, I'm worried about the stimulus checks because I think it really is going to affect inflation. I think the value of the dollar is going to go down because of so much stimulus um, being given from the government, right? And the second person B, we'll say, was also a dude. He said, well, you must not care about people that are suffering right now because they're out of work because of the pandemic. So the idea was, person A was just worried that the stimulus checks would deflate the dollar, right? But then person B made the conclusion, oh, because you feel that, you must feel that you must not care about the student, or not students, some students, but you must not care about the individuals that are really suffering right now, that really need that money to get by. And this is actually like, as it was happening, I thought, oh, this is a beautiful example of straw man. Okay, this is, if you look at the way they define straw man, excuse me, the way they define straw man, it was just like that. And I forgot the example that they did. It was something about a mayor, I think, and his proposal. But it is a beautiful example of straw man where you're not really attacking. It's kind of like diversion. You're not attacking the argument, right? I mean, the argument is that the premise is that, hey, I believe increasing the stimulus creates a deflation of the dollar, right? That's the premise and the conclusion. But whenever you go after, oh, you don't care about the people suffering, which that person, I know that person personally, he does care about those kind of things. He was just worried about the dollar because in the end, he believed it would hurt, people long term, right? In a different manner. So it was interesting. So you're not attacking the person's premise and conclusion, or how they came to that conclusion based on the premise, right? You're going after you're going after other kind of arguments there. I thought that was interesting. That was a good one that I noticed in real life. And then my favorite one, just because one was that way, we're gonna try to get left or right. I love the political clash that's happening on Facebook or on social media, because it is full of fallacies. And this is on both ways. I'm just going to choose one example. I don't want you to think that I think one way or another based on it. It was just what I saw on my social media, and from someone that I'm related to. And I got a kick out of it. And it said, you voted Biden. You voted for Biden. You must be a communist, right? You support communism. That's what it was. So the premise is that if you voted Biden, the conclusion was that you are a communist. You support communism, right? And I had to look at how, I'm not sure which one this really goes into. I believe it's limited choice, though, in the book, where it's like there's only there's a limited option. Like, if you support this guy, you must support communism. So that to me seems like a limited choice or a false dilemma, where you don't. If you support Biden, that does not necessarily mean that you support communism. Now, it might, but that's not how. That's a very limited conclusion that the person that was making that statement believed. Okay. Now, if you want to logically kind of get there in other ways, that's your own prerogative. But you can't say if someone chooses to support one candidate, then automatically, boom, that they are a communist, or they're a tree hugging hippie, or whatever you want to, however you want to make fun of that political figure or the people that follow them. Okay, so those were some good examples that I noticed and that you guys sent in. If you see more, I would really appreciate you sending me examples of it so I can use it later on, and we can kind of see what which fallacy it lines up with, and really just, you'll notice them all the time. Hopefully you notice them. That's one of the goals I want for this class, is that you notice some of these fallacies that, because we're all biased, guys. We're all biased. This happens. Of course, I'm going to be biased towards one party or the other, but I have to realize, hey, I am biased when I read these things, and you get sucked in, and then you've got the algorithm after you that really kind of just feeds you what you want to hear after a while. But just be careful. Be careful. Please be careful when you really 1A. I think it's just be careful about reading the news, right? Be careful about reading the news. Be careful about watching the news. It's really, you can use it for information, but you have to be careful, because the news and social media on an extreme level is full of these fallacies where, if you support this, just for instance, if you support this candidate, you are this type of person, right? And whatnot. So it just be careful. Be careful, please, 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 because then you start making those assumptions and you think they're true. I say you. I know. I mean, I've been guilty of it. It's like, oh, I think it's true because my conclusion now is, well, I saw it on the news. It's got to be true, right? Which makes it feel sometimes like a true premise. You know, like, oh, that's a truth. I can make that assumption, but really, you have to realize it's based on a fallacy, right? It's based on a fallacy. And damn it, can we all just get along? Eventually, maybe. Okay, so now I want to open it up for any questions. If you guys had any questions from 1A or 1B, I don't remember. I don't think anybody emailed me questions about 1A or 1B. But I don't mind going over any questions right now if you had any. And if not, we're going to go right into 1C. I'll tell you, today I think we're just going to be able to get through 1C. We might try to get through 1D, or I might kind of assign some stuff from 1D, but definitely, oh yeah. We're definitely going to hit 1C. Okay. So then, 1C. I mean, actually, we're going to be rocking and rolling. Okay, so let's look at 1C. I'm going to switch over to the document camera. Actually, yeah, I'm going to switch to the document camera. We're going to do a little bit more writing today than necessarily, and then kind of, just face-to-face lecture. Let me move this over. Boom. Okay, section 1C. If you've got the book, if it's come in, this is on page 25. And today we're going to go over sets and diagrams. Hold on. There we go. Sets and diagrams. And we're going to use these eventually we're going to use these sets and diagrams to show true conclusions and to use argue ourselves into true conclusions in a way. Okay, so first off, your book defines sets. And it says a set is a collection of objects. I'm just going to leave it there. Set is a collection of objects, and these can be living or non-living. It doesn't matter what they are. A set is just a collection of objects, and then it defines member, and it says member is the members of a set are the specific objects within it. So I'm going to say objects within a set. Okay. Very basic example of a set we can use today. Oh, actually, your book then goes over set notation, so I'll use this. Oh, good. You guys all have different first letters of your first name. So if I was going to go over students that are in class today, so the set is all the students that are in my class today. That's the collection. Each one of you would be a member. Okay, so I'm going to just use the first letter of your first name that when you got into Zoom today. So the way we would do set notation to show this set is you use, I call this a squiggle bracket. Do they give it an official name? They call it braces. You would open up a brace. So it's not a parentheses or a bracket. It's got that squiggle in it. So it's a brace. And then you would just write the objects, the members of the set. So I'm going to just write your first letters, the letters of your first name. So you got W, A, E, and S. Okay, and U4 would be the collection of objects for this set, and so this would be the set. So if someone that's not here would of course not be in this set because they are not a student in the class at the moment. I wouldn't be in this set because I said it was students that were in class, right? It's just the set of people that I have defined. Okay. Your book goes over different kinds of sets. I know this is goofy. This is more about the notation, okay, and definitions. So it's a really basic concept. Set and members are a very basic concept. But we have to understand that we have to use braces. And then it's parentheses to separate each member of the set when we have a distinct set of members. Well, I don't think in this section we'll talk about continuous groups. Like if I said all the numbers between 5 and 20, well, there's an infinite amount of numbers between 5 and 20. We wouldn't use parentheses or we wouldn't use commas for that. You wouldn't say 5, 6, 7, 8. because there's an infinite amount of numbers between 5 and 6. You would use a continual notation. We're not going to talk about that, I believe, today. Today, we're talking about very distinct members in the set, okay? Maybe it was whole numbers between, 5 and 10. Well, 6, 7, 8, 9, right? Okay, so your book thing just goes over set notation, not a big deal. Then it defines it. Okay, so yeah, let's just do kind of some basic ones. So if I said numbers, wait, did I talk about, hold on. Yeah, let's say whole numbers. Greater than 6. Whole numbers greater than 6. So whole numbers are counting numbers, right? 6, 7, 8, 9, 10. But we want whole numbers that are greater than 6. So I'm going to use my bracket, or my brace, I should say. Now I'm going to start at the very first whole number that's greater than 6. That's 7, right? 8, 9. And of course, we could go forever. So if you can go forever, you can use dots, okay? You can use period or just an extended dot. So you would put let's say I only want to go to 10. You'd use a comma, and then you would just use dots. And what that means is it would follow this pattern forever. Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15. And of course, there's an infinite amount of whole numbers greater than that. So that's how you would notate it. Okay, so if we did have a set that was, it's kind of open-ended is the way to think of it. If we had a set that was open-ended and it went forever, or we'll do an example here in a minute where there's just really a whole lot of options. You would use these dots, okay? So that's one goofy thing that could happen. If I said the set of all years, I think your book does this example, between, let's say 2005 and 2021, okay? Between us and including, okay? So we're going to include the numbers here. So between and including 2005 and 2021. So this isn't open-ended because we start and stop. So if we're going to use the dots to fill it in, we would have to include the last year because we know what the last year is. So we could do 2005, 2006, 2007, comma, comma, 2021. Okay, so it's like 1, 2, 3, skip a few, and then the last one. Okay, and we get this, right? This makes sense. Okay, these are all the years between 2005 and 2021, and then we don't have to write them all out. We just write the first few. The dots mean all those numbers in between, and then 2021. So when it's not open-ended like the last one, we could do something like that. Okay. And then if we just had, oh yeah, okay, set of all, now we have to probably make a definition of a fast food chain. Let's say fast food chains. So this one isn't like an ordered thing per se, but there's just a lot of fast food chains, right? And how about this? In the chat right now, just so I can make sure that you're alive, I want you to put your fast food chain that you like going to, or maybe we don't have in town. So when you're out of town somewhere, you have to go to it. And I can tell right now I'm hungry if I'm talking about fast food chains. I'm going to give you a minute. So to show me that you're there, just pop it into the chat. If you don't know how to get to your chat, you can just tell me over. You can unmute yourself. Oh, Panda Express. Hey, Jack in the Box, those tacos are so good. They're only like $1. Yeah. Chick-fil-A, that's what I was going to say, Weston. That Chick-fil-A, that chicken. Jesus, chicken is good. The Chick-fil-A sauce. My wife turned me on the Chick-fil-A sauce a few years back. Okay, Savannah, are you there? If you're struggling, that's fine. That's okay. It's no big deal. Just let me know if you think of one. Okay, McDonald's. Yeah, classic, right? Okay, good. And look, we could go on and on. I mean, we've got all kinds of fast food. I mean, we got Whataburger, Arby's, Wendy's. I mean, there's a ton of fast food chains, right? So what we can do actually is if we're going to make a set of all of them, we can just write a few down and then use the dot, dot, dot. So a lot like the open-ended example from before, okay? So if we had, I'm definitely putting Chick-fil-A. My wife would be upset with me if I didn't. Chick-fil-A. And then, yeah, we'll do McD's. And then Jack in the Box. We'll just do J and B so I don't have to write it all out. And then we got Panda Express. I do like Panda Express. And then, okay, so I know we're out of room here, but then you can just use dot, dot, dot. Because it understands, look, there's too many of these. We would spend all day writing out chain restaurants that we like to go to. Okay. So we just spend forever. So you can, if it's a generalization type set, you can do this as well. But realize this set is all fast food chains. Okay. All fast food chains. Right section for this notation. Sets and diagrams. So here we go. Okay. I think that's all the kind of examples that could happen. Do you guys have any questions on what you think maybe something goofy could happen, or questions about just the way this is written, the notation? White Castle, yeah. That's one of the dot, dot, dots right there. It's White Castle. Crystal, if you're from the South. Okay. Okay, good. So let's go on to the next topic in 1C, which is over Venn diagram. So your book, which is kind of neat, it talks about the Venn diagram namesake, which is after a person named John Venn, who was an ordained priest who wrote books on logic, statistics, and probability. And he also wrote a history of Cambridge University, where he was both a student and teacher. Though well respected for many of his contributions to logic, he is best known for his diagram that bears his name. So this is called the Venn, V-E-N-N diagram. The Venn diagram. Now, it's a way to illustrate really objects that are in and out of a set, or that kind of overlap with other sets. That's a kind of a very basic way of going about it. Oh, yeah. So first off, let's think of pets. Okay, the pets is a really good example of this. So I'm going to say, with a Venn diagram, you're going to use a rectangle. Okay, rectangle. And then we're going to use bubbles, okay, or circles, I should say. You can even think of them as bubbles. But each circle, if we're going to look at, this one's going to be about pets, okay? For this example, each circle is going to represent a type of pet, okay? So each circle is going to represent a type of pet. And actually, I'm only going to do 2 circles here. I'm running out of ink in this marker. Let's see if we go. I'm going to do dogs. We got dogs in this bubble, right? We got all our favorite dogs. We've got, the Westie, which is the dog that I have. We've got German Shepherds. We've got Labs. We've got Golden Retrievers, which are awesome as well. All the different dogs. We got Heinz 57 dogs, Arkansas Black Dog. All the dogs you can think of are in this set, okay? And all the dogs are in this set. So this means all pets that are not dogs are in the rectangle, but not in that bubble, okay? So that's a basic Venn diagram. You've got dogs, and really all this space outside of the circle here, but still in the rectangle, would be not dogs. So dogs, not dogs. Well, let's say we introduce another pet. Let's say cats. Well, cats would not overlap with dogs. Cats are not dogs, even though there are some cats that act like dogs. So we've got cats in this bubble, right? We've got dogs. We've got cats. I should make them plural. We've got all different kinds of cats, which are mainly just mean and not mean, That's how I think of cats. I don't know. I don't really know different kinds of cats, but all the mean, non-mean cats are all in this bubble, right? So if you're not a cat, you're in this. I mean, of course, you're in the dog bubble, right? Dogs are not cats. And then you're also in the square, right? So anything that's any pet that's not a cat is going to be in this area, okay? This is a basic Venn diagram. So that means anything that's not a dog or a cat, and I'll kind of fill this in, is right here. Anything that's not a dog or a cat is in that green space, okay? So you got dog, you got cat, anything else is in that green space. So let's say you have a pet lizard. Well, your pet lizard, Larry the lizard, we'll call him that, is out here in this rectangle somewhere, okay? He's not going to be in the dog bubble. He's not going to be in the cat bubble. He's going to be out here somewhere, okay? Sure. Yeah, this is an example of a disjoint set, okay? Dogs and cats here are disjoint. Now, your book defines this disjoint set. I'm going to read it here fast. It actually uses dogs and cats too, yeah. We draw the Venn diagram with separate circles that do not touch, and we say that dogs and cats are disjoint sets because they don't touch, okay? Dogs and cats are disjoint sets. Disjoint sets. I'm going to use not because they don't touch. I like the word overlap because they do not overlap. Not overlap. That's a type of dog, but overlap. Okay. They do not overlap, so therefore they're called a disjoint set. A disjoint set. Well, let's look at sets that overlap. Your book uses one. Let's use let's not do one in the book. Let's make one up. We're humans. We're creative, right? I'm going to ask you to make one of these up here in a minute where we've got disjoint and joint. Actually, they use disjoint and overlapping. Let's say we looked at, I guess we can go gender. Let's say we looked at two different areas. Let's say we looked at a certain, hold on. Okay, yeah, let's look at where our students come from on campus. We have a lot of students. I mean, you guys know this. We're in Mountain Home, Mountain Home, Arkansas. We have a lot of students that come from Mountain Home High School. So let's say we looked at where students graduated from. That's our first bubble. So our first bubble here is going to be Mountain Home. We'll call it Mountain Home High School. So the student came from Mountain Home High School. So if you're not in that bubble, you graduated from a different high school. Okay, we'll just look at students that are done with high school. Okay, so if you graduated from Mountain Home, you're in this bubble. If you didn't graduate from Mountain Home, you're outside of this bubble, okay? So you got Mountain Home students, and you got non-Mountain Home. I say non-Mountain Home. You graduate from Biola, Cotter, or somewhere, somewhere far off, wherever you guys are coming from, okay? So Mountain Home graduates, non-Mountain Home graduates. So that's our first bubble, and we're looking at students on campus, okay? So these are all students on campus. And then let's say the second bubble is, let's say gender. Let's go with males. Okay, so we're also looking on campus. We have people that identify as a male and female. Okay, we're going to stick to that, male and female. So all the males are going to be in this bubble, and all the females, we'll say there's only two for this example. So all the females are going to be not in this bubble. So what happens is there's overlap, right? Of course, we could have people that graduated from Mountain Home High School and that are male. They get this overlap here. But it really, in a way, it partitions off 1, 2, 3, 4 different areas here, okay? This is called overlapping. Do they call it overlapping sets? Yeah, overlapping sets. And up here, look, with non-overlapping sets, if there's just two, we only have 3 areas, right? We got dog, cat, and neither dog or cat. with overlapping sets, it can cause a lot of different areas, okay? And really we have, and I'm going to try to use different colors here to help you out visually, but we have 1, 2, 3, 4 different sets. Let's talk about the overlapping set first. Okay, this is this brown color right here. If someone's in this set, that means they graduated from Mountain Home and they're male. Okay, they graduated from Mountain Home and they're male. That's if they're in that brown set in the middle. Okay, let's use a blue. Actually, I'm just going to use arrows, and wherever the arrow ends is going to be here. So if you wound up in this set, let's think about this. Look, we're not in the Mountain Home bubble. That's here. We're so we're not from Mountain Home. We didn't graduate from Mountain Home High School, but we're still male. Okay, so if you wound up in this part of the bubble, and you kind of think of like, if we had all the, the students on our campus in this one rectangle, and we partition them off, the ones that wind up in this part of the rectangle are not from Mountain Home, and they are male, right? They're still male because they're in the male bubble still, but they're not in the Mountain Home bubble. So right here, we're not from Mountain Home, right? We're not in the Mountain Home bubble, but we do wind up in the male bubble still. So we're not from Mountain Home and we're in the male bubble. Okay. So let's use the green color for this set here. Okay. So right here, if we wound up in this partition, we're in the Mountain Home bubble, but we're not in the male bubble. Now look, I know you're going to want to say, oh, that means we're female. And I mean, that with logic, we're not going to say that because all we've defined is male. So therefore, we're going to say not male. Okay. Just like over here with Mountain Home, how we said not from Mountain Home because they weren't in the Mountain Home bubble, we're just going to say not male. Now, I don't care where you wind up on your beliefs on gender and all that crap. I shouldn't say crap. That's not what I meant. That came across harshly, actually. But no, I don't mean it like that. It doesn't matter about how you define gender. What we've defined is male, and that means everything outside of the bubble is not male. Okay. If we want to go into other conversations about gender, I'd be more than happy to actually, but that's another day. Okay. Another topic, another day. But for now, we're just defining male and not male. So inside this bubble, we've got Mountain Home, right? And not male. Okay. This is the Mountain Home bubble, and they're not male because they're not in the male bubble. Okay. Now that comes from the overlapping. We still have the students that are in the rectangle that didn't wind up being in a bubble, or two bubbles in a way. Okay. So that didn't wind up being in a bubble. Let me see if I've got another. I got orange here. Okay. So the students that are in the rectangle, then let's think about this. They're not in the male bubble, and they're not in the Mountain Home bubble, right? They're not in the male bubble. They're not in the Mountain Home bubble. So I'm going to put it like that. Now, it doesn't matter about the order, but I've been consistent with where they're from first. So they're not from Mountain Home, and they're not male. Okay, they're not from Mountain Home, and they're not male. So we have every single part of this Venn diagram filled in, right? If I told you that we pluck somebody out, actually, let's say okay, so I'm going to assume that someone in this class, let's say we know someone that's not here, some guy named Joe, okay? And I know that Joe winds up being right here, right? There's Joe, okay? Because he winds up in that bubble, I can make an assumption about Joe. One, he's male. He's in the male bubble. Two, since he's not in Mountain Home, the Mountain Home bubble, he's also not, he didn't graduate from Mountain Home High School, right? He didn't graduate from Mountain Home High School. So Joe's male, or because he's right there, he's male, and he did not graduate from Mountain Home High School, okay? Where if someone wound up out here, I could say, oh, well, they're not male, and they also did not graduate from Mountain Home High School, okay? Excuse me. And what should happen is that every single student on our campus, like you four that are in here, you're in this Venn diagram somewhere, right? You're in this Venn diagram somewhere. Oh, well, unless you're a high school student, you're in this Venn diagram somewhere. If you want to put that, if you're from Mountain Home, you can put yourself in the Mountain Home bubble. If you want to, that's a-okay. But you do wind up being in the Venn diagram because this was the Venn diagram of all students on campus, all students at ASUMH. Now, of course, we can have a ton of other bubbles. We can have a bubble for students that are on the Pell Grant. We can have a bubble of students that are veterans or not veterans, right? We can have a bubble that of students that are in, let's say, the mechatronics program and then not mechatronics program. So, and we'll do one with more bubbles here in a minute, but this is a really good example of overlapping sets, okay? So overlapping, we wind up with a group in the middle that's both of those sets that we've kind of defined. And then in distinct or disjoint sets, there's not going to be overlap. Dogs and cats don't overlap. Mountain Home students and gender do overlap, right? Male and gender do overlap. Okay. Oh, yeah, there's one other example that I didn't talk about that you brought up first is, do they define what this set is? I don't really define it. Hold on. Oh, subsets. Yeah. Okay, subset. So we've got subsets, and let me think of an example. Your book does a good one about mammals and maybe we'll stick to that. So let's do subset with animals, which is always fun. So let's say we've got a Venn diagram of all the animals we can think of. Or that exist. How about that? All the animals that exist. And one way that we've kind of partitioned animals out is by, your book does this, but it's fine, mammals and non-mammals. So we'll make a big bubble here. And we'll call it mammals. So all the mammals wind up in this bubble. Now your book does whales. I'm going to do different animal. But we've got all the mammals in this bubble. So that means all the non-mammals are out here, right? And if it's a subset, it means that we just have another set inside one of our groups, okay? So let's say for mammals, a subset could be dogs, okay? Should have made my bubble bigger. But we've got a subset of dogs inside mammals. Really, in a way, mammals are a subset of animals, right? I mean, this is the whole set of animals. A subset of that is mammals, and a subset of mammals is dogs. So if I wanted to look at my dog, which is a Westie, she would be right here, okay? Right there. There would be Zoe, the Westie. And that's where she's at. Now, we could also look at another subset that's a non-mammal. So what's an animal that's a non-mammal? Help me out here. I'm going to put him over here. Is a snake a non-mammal? I think it is. I don't teach this stuff. Snake, perfect. Okay, thanks, Emily. We've got snakes, right? Snakes are over here. Now look, they're not in our mammal bubble. They're in the non-mammals, which is out here, and there's a whole subcategory of snakes, right? There's a bunch of different kind of snakes. Rat snake. We've got the blue racer, all that the cool snakes. So they're all there, but they're not going to be inside the mammal. That set of snakes is not going to be inside the mammal, but it does take up a whole set. So really, dogs and snakes would be disjoint, right? They wouldn't overlap. But also snakes and mammals would be disjoint because they wouldn't overlap. This is going to lead us into some logic and practical reasoning, ideas today and tomorrow as well. Okay, so we've got 3 sets now. Dogs would be a subset of mammals, but snakes and dogs are disjoint. They're not overlapping, but snakes would be a subset of non-mammals, right? All the stuff in the rectangle that's not the mammal. Okay. Yeah. In your book on page 29 at the very top in the kind of green bubble here, it gives those three different examples where you've got subset and then you've got disjoint and you have overlapping. Okay, so I'm going to stick to that. I'll tell you, if you look this up, maybe like on YouTube or if you want to look it up, they might use different words, but so I would stick with disjoint, overlapping, and subset Venn diagrams. So if you do want to kind of look up some more examples of this, then you're more than welcome to. Okay, so I'm going to put this out to you guys now. And in the chat, I want you to think of, don't use the book. If you're looking at the book, there's some examples of this. I want you to think of, and okay, look, here's the rules. No animals, because we already used animals. I want you, and gender. I want you to think of things that would be disjoint sets. Okay, disjoint sets. And just pop them in the chat. I'll give you a minute for disjoint sets. Actually, Emily, and this is weird that you said that, there's this commercial out of Springfield, and there's this guy in it that's a lawyer and a doctor. So you can be a lawyer and a doctor, but typically you are correct, right? Typically, Emily, that's true. And I know it's so weird. It's, he's just one of those guys that has the commercial, but because, look, I'll tell you, Emily, though, because there's that one guy that's a lawyer and a doctor, we can't assume that it's disjoint. Right? I mean, you can go to law school and then you can go to med school. There's nothing wrong in that, right? Okay. I'm glad you said something, though. Glad you brought something in. I mean, if you guys want to just unmute yourself and give an example, that's fine too. And it's okay if you're wrong. There's nothing wrong in being wrong. So we can talk about why you're wrong. Why your brain inside and outside. Ooh, I don't know, Ava. Hold on. Can you think of an example where you would be inside and outside at the same time? I'm not saying you're right or wrong. I'm not saying you're right or wrong. I'm saying,
cave.
Say it again.
A cave.
You know what? I think that's a perfect example of where you could be inside or outside. And now look, a lot of these are kind of how you define it, right? I wasn't thinking cave. I was thinking, those like sometimes if you go to like restaurants or buildings, they'll have like an inside patio, like hotels. They'll have like an inside patio where you feel like you're in the building, but you're not really in the building. But yeah, cave is a good example. You're definitely in shelter, right? So I like the idea though. It feels like inside and outside are disjoint. Now you might say like inside a building or outside a building, but I want you to think of like two totally different sets of things, separate kind of groups maybe. If you think of like groups, maybe groups of people. Like if you want to go down that route, like this set, that's it, Gosh, that's good. It shouldn't be hard, right?
I don't know, like an RV and like a stationary home, like.
Beautiful. Okay. Well, hold on. Anyway, I'm gonna switch that up just a little bit.
Okay.
But that's a great example. How about type of vehicle? We'll go that route. Beautiful. Okay. Type of vehicle. Okay. I'm gonna switch down to the thing here. So type of moving vehicle. So we got all these vehicles, and I'm going to put RV on one side. It's a vehicle, right? It moves. And then I'm going to put sedan over here, right? I know that's not what you said, but I'm just going to go that route.
Yeah.
Yeah. Those two things are definitely disjoint groups, right? Now, if you've got an SUV, it's going to wind up, in the rectangle somewhere. But you've got an RV and you got a sedan. Now, also, to kind of expand this out, if I looked at sedans, Ooh. Another type of vehicle is a hybrid, right? You guys agree? We got hybrids. Now, not all hybrids are sedans. I was going to say they are, but they're not, right? I mean, there's hybrid SUVs now. So let's say someone said, well, where would hybrids wind up? Now, I don't know. I don't think they make a hybrid RV. Those things are huge. I know they run off batteries for other parts of what they do, but I don't think there's a hybrid RV. So let's say someone said, well, what about hybrids? I would put hybrids right here. Okay. Now look, hybrids would still be disjoint from RV. You guys see that? Because I don't think they make a hybrid in RV. Now if they do, we'd have to overlap it. But I know they make hybrid sedans. That group would be here, right? But then like a muscle car is going to be in this part of the sedan bubble, which muscle cars aren't sedans, but a more souped up sedan. Where like a hybrid SUV would be in this part of the bubble. Okay. That's a great example. That's a great one. Okay. And then I said, okay, well, let's look at another example where we have like all three overlap. Let's say, let's go back to students on campus because this one's kind of easier. And I'm going to make the example kind of bigger here just because we're going to have three bubbles. Okay, so let's say this first bubble is going to be, let's define people by their major. Okay, this bubble will be all students that are in the ASB degree. Okay, the Associate of Science and Business. So if you're in that Associate of Science Business, you're in that bubble, right? No big deal. But so you're in that bubble. If you're not, then you're in all the other degrees, the AA degree, the ASG, the AAS, mechatronics, all that other stuff, right? I say other stuff, it's just everything but the ASB. So we got the Associate of Science and Business, which transfers to four-year schools for a business degree. You're in that bubble. But all the other degrees are out here, okay? So that's one of my bubbles. Let's do another one. I'll use a different color here. Straight up running. Let's do another bubble, and let's do this one with, let's do students that live in Baxter County. Okay, students that live in Baxter County. So if you're in the green bubble, you live in Baxter County, right? If you're not in the green bubble, if you're out here in the rectangle, you don't. So again, we have overlap. So this overlap right here would mean students that live in Baxter County and they're in the ASB degree program, right? They're an Associate of Business degree. Okay, so we got Baxter County, we got ASB. Okay, let's do one other bubble here. Okay, let's do a veteran, someone who was in the military and now they're not in the military and they're coming back to school. We have a lot of veterans on our campus. We have a great program, actually. Sheer Hughes, who runs that thing, is great, the Veteran Affairs program on campus. Okay, so now we've got another bubble that says you're better. Now look, we have we actually have a ton of overlapping bubbles in reality right on campus that we all fit in. Now some bubbles aren't as clearly defined on the circle in or out, but these are pretty clear. You live in Baxter County, you are an ASB, and you're a veteran. So if you meet all three of that criteria, you would, boom, be right there, right? That would be you. If you are a veteran, you live in Baxter County, and you're an ASB student, you're in that bubble, okay? But let's say, you are a veteran, you live in Baxter County, but you're on the AA degree. You're in the Associate of Arts degree that transfers, to 4 years. So you're a veteran. You're in this bubble. You live in Baxter County, but you're not in the ASB program. So you would just be right there, right? That would be you. This makes sense? You give me a thumbs up if this is making sense. how it's kind of partitioned out. The goal here is really just to see how we partition this out. So let's say I went and asked a student these 3 questions. Just, are you a veteran? Do you live in Baxter County? And are you in the ASB program? And they told me, you know what? We'll call this person 1. Not a vet. They do live in Baxter County. But they are not in the ASB degree. So they're not a vet, so they're not in this bubble, right? They live in Baxter County, so they've got to be, okay, hold on one second, Ava. So they've got to be in this bubble, right? And then they're not in the ASB program. So now let's think about this. So they've got to be in Baxter County, and then they're not in the ASB program. So they're not a vet either. So this person, we'll call them person 1, would be right there, right? They're not a veteran, so they couldn't be here. They would be in Baxter County, so they'd have to be in this bubble, but they're not an ASB, so they couldn't be in any of these 3 groups, right? So they have to be over here. Okay. Okay, let's get to Ava's question. What about groups like this? Yeah, that are, straight, bi, trans, gay. Okay, I know it gets more complicated than that, but that would be a good example. Yeah, no, you're right. So you got to think the way the Venn diagram works, and it's a really good question, Ava, is you're either are or you're not. So you could look at, and that's what I said, how some of the groups aren't as clear, but if you were going to define someone by their sexuality, you might have a lot of bubbles, but I'm going to tell you, I am not that familiar if they overlap or not. But like, let's say, and trans is different because that's gender, but like if the straight, bi, gay, and bi. So straight, you would think of it as the straight bubble and non-straight bubble, right? So I'm going to do a horrible attempt at this, and I want to apologize. Honestly, I'm going to apologize if I offend somebody because I'm not an expert in this stuff. Okay. But let's say we looked at sexuality, or what you choose your sexuality to be. I'm not, let's run out. So let's say we've got the straight group here. So that means if you believe if you're straight, I don't know if you choose, I'm not going there at all. Okay, but we've got students that, let's say we made them fill out a survey. We had students fill out a survey, and the ones that replied they were straight are in this bubble. And the ones that are not straight would just be out here in the rectangle, right? And there's nothing wrong with that. So we got straight, non-straight. Now, it depends on how you define gay. So if you ask another, same question, but you couldn't choose twice. So that means you can't, if you believe you can't be straight and gay, that would be disjoint, right? You'd have the gay bubble here, right? So you'd have the gay bubble here, the gay circle, and it would be here. And then look, there's other sexualities, right? It's not just straight and gay. And you kind of define one bi, right? So someone that's bi would be in this area. I hope that's helped. I know that's, it's not the easiest topic to cover there, Ava, but I think with the way I understand it from a very layman way of understanding sexuality, roles and things like that, you'd have like the straight bubble, non-straight, and then gay wouldn't be covered in straight. It would be disjoint, right? And then other sexualities would line up around here. No, it's not complicated. And, these are good things to talk about. There's nothing wrong in opening up conversations. But we do have to remember this is a math class. So whenever it comes to like other, things involved with sexuality, I'm not going to go into. But on a Venn diagram, we can definitely talk about it. And again, it's hard sometimes to do Venn diagrams because of the overlap. We're all human, right? And so the way you really define it is you are or you're not. Like that example, and I forgot the inside outside example that you brought up, Ava. It's almost like that. Like if you can think of a place that's inside and outside, I guess it could have overlap, but in the end, you're defining, like if we said, hey, this is inside and this is outside, then there's some other side if we wrote it like that. Okay. So this wouldn't, I just didn't, that's why I didn't really include it in this example, because there's inside, outside, other, and then overlap, which the overlap I can think of, right? The cave. Cave would probably be here. But is there in something that's not inside or outside? I don't know if I can think of something that's not inside or outside or overlap. If you do, then we could definitely use this example. This is good stuff. This is a good conversation. Okay. Man, I'm running out of time. We're definitely not going to get to part B. Okay. For time's sake, I do need to keep moving on. Yeah, I want you to look on page 30. It goes over categorical propositions. And actually, we can talk about this. This won't take long to talk about. There's 4 categorical propositions. The first one is that all SRPs. So what that means, let's do it with an example. Let's say all, hold on. They did whales. So we did dogs. All dogs are mammals. This would be a categorical proposition. So we're placing dogs inside mammals. So what this means is we have a subset of dogs that are inside mammals. And we know that this is true. We did the Venn diagram already, right? You had mammals and then you had dogs in here. So mammals and dogs, okay? So all dogs would be mammals, and this is how we would draw it. The next one would be like no blank or P. So for this one, if we could say, let's say no lizards are mammals. And that way we can use the same Venn diagram. If we said no lizards are mammals, it would mean that the circle would be outside of this. And this creates the disjoint set. Okay, lizards would be here. We got lizards and we've got mammals, right? And you could even say no lizards are dogs, right? That would be the disjoint set. Now, when we get into the some and some are not, it's the same dang thing, okay? So your book then says, well, what about some doctors are women? Or you can say some doctors are men, it doesn't matter. But your book says some doctors are women. Now, what that means on the Venn diagram, we kind of shorthand this one. We've got those 2 sets and they definitely overlap now, right? We've got doctors and we've got women, right? And then what happens is some doctors are women. That's just this set right here. We've been talking about it already, but if we said some doctors are women, or we could say some women are doctors, right? We can crisscross that. Crisscross, we can flip it, invert it, right? Converse. Some doctors are women, some women are doctors. Yeah, inverse that statement too. So, and it would be fine. Some women are doctors, right? And there's nothing wrong with that. Now, you could say the same thing though, and say some doctors are not women. And I can use the same Venn diagram. And if I said some doctors are not, it's going to be the doctors that are not women. So that's going to be that group right there, right? Not the one that overlaps, because those are doctors that are women, but some doctors that are not women are in that bubble. We've kind of talked about this already. We just didn't make those statements. They're called categorical propositions, and they're on page 30 if you want to look over. If you think I'm going too fast, there's nothing wrong with that. We went over that. I'm gonna get to the numbers. Yeah, Venn diagram with numbers. This is the fun stuff, okay? And I've got 15 minutes to talk about it. But now we're gonna talk about Venn diagram with numbers. What if we actually had the number of, students, like earlier, we talked about students that are from Baxter County or veterans, things like that. What if we had the numbers? How could we do this? And I'm gonna steal the example straight out of the book. It's on page 34, it's table 1.1. It talks about the distribution of 350 births by weight, status, and mother's smoking habit. So we've got weight, and they defined it as low or normal. Okay, and then we've got smoker and non-smoker. So notice we have bubbles here, right? We have, now we're going to fill the actual numbers here in a minute, but we have two separate bubbles. We've got the smoker, mom, and then we've got the low birth weight baby. Low birth weight baby. So look, and this is going to define all 4 of these groups. So let's look at this. It tells us that out of this 350 births, 18 were low, had 18 were from smokers and they had a low birth weight. 132 were from smokers and they had a normal birth weight. And then for non-smokers, 14 had a low birth weight and 186 had a normal birth weight. So let's fill this in now. So now we can fill in our bubble with actual numbers. We have we have 4 parts here, right? We've got the smoker mom with low birth weight. So if your mom smoked when she was pregnant, or I say your mom, if the mom in this example smoked when she was pregnant and the baby had a low birth weight, it's going to be in this overlapping bubble. And we know that one. Low birth weight smoking mom, that's 18. We had 18 babies like that out of 350, right? I'll put that here, 350 births. Sounds funny, but 350 births, okay? Now, this bubble right here, this portion of the smoker bubble is moms that smoke, but they had a normal birth weight, right? Not low, but normal. You can say not low if you want. I wish they would have done that. But they called it normal birth weight. So 132 lined up right there, right? You've got 132 moms that still had a normal birth weight, but they smoked when they were pregnant. Now the bubble here, we got low birth weight, but then they weren't a smoker. So I think that was 14. Yeah. 14 babies had a low birth weight, but they came from a normal or a non-smoking mother, okay, that wasn't in this bubble. And then lastly out here, we've got normal weight. So the rest of the rectangle would be a normal weight baby from a non-smoking mother, which was 186, okay, 186, which is kind of cool, okay, pretty cool. And look, you can do this with numbers. We could flip this around and make it into percentages if we wanted to. There's nothing wrong with this. If we're looking at these 350, look, I've got my calculator, just a calculator out here. If I wanted to write these in percentages, there's nothing wrong with that as well. And sometimes it gives us a better idea of what's going on. So I'm going to do the same thing. So we've got these 350 births. Got these bubbles. And I've got the smoker mom and I've got the low weight baby. Okay. And instead of numbers, I'm going to write them as percent. So it's out of 350. So 18 out of 350 is, and I'm going to round it to the first decimal in the percent. So 5.1% of babies wound up coming from a smoker and a low weight mom. Now, what about low weight and non-smoking mom? So that's 14 out of 350. So that's 4%. Exactly, actually, 4%. Okay. And then the smoker mom that's a normal birth, or that's a normal weight, would be, was it 132 out of 350? That's 37.7%. Okay. And then lastly, we have everything left over. Now, look, you could just take 100% and subtract all 3 of these, and you're going to get what's left over, right? Because it's all the other babies, right, that are normal weight and from non-smoking moms. Or you can do 186 divided by 350 and get 53.1%. Okay, 53.1%. So look, if we just looked at the low weight bubble, we can see, look, more babies are coming from smoker moms, right? If your baby is a low weight baby, you've got a higher chance, 5.1% compared to 4%, right? If you're a low weight baby in this study, you've got a higher chance of coming from a smoker mom than a non-smoker mom, okay? Which is kind of interesting. Oh, good. That's it. Okay. So for homework, so this is section, we're going to stop here, guys. Section 1C. And the homework, I think I've already pulled up here a second ago. Did I left me. Give me just 1 second. I'm going to get in. It's in your Blackboard, but I'm going to just give you it as well. So if you didn't want to look at, dig through Blackboard, course schedule. It's 1 through 85 odd, and it starts on page 36. So page 36 in the book. Now, guys, I'm going to tell you, I'm already behind, right? This is, oh, actually, yeah, no. So if you're watching this later, I'm already behind. We were supposed to do 1C and 1D. So what I really want you to do, I want you to do the homework, but also I want you to read 1D. 1D is really, it's an easy read, and it's about induction and deduction in mathematics. So I'm going to put that in the homework. I want you to read section 1D. Okay, read section 1D. Now, for this class, which is in the spring 2021, I might use this video later, okay? For this class, which is spring 2021, what I'm going to do is I want you to read that. At the beginning of class, we're going to go over 1D as if you've read it, okay? And then I'm going to go based off questions that you have from that. You can start on the homework. It's in your schedule as well. What is it? 1 through 71 odd. Okay. And it's okay if you can't get all the way through it. I'll really go over it a little deeper in the next class lecture. But I want you to do this homework and then read section 1D about analyzing